Live and in color with HD where available from the world headquarters of the McNeil International Film Studios. I'm here to talk today about relationships. Not Brad Jelena kinds of relationships, more
Spidey.
mathematical kinds. What?
Spidey.
Relationships. There are relationships between things, and what that means generally is if one thing changes, it will cause a change in the second thing. Now, the change can only be, that is, the relationship can only be demonstrated by theory. You can't just do it because one thing follows another. That's a fallacy called post hoc ergo propter hoc, or association is causation, probably in your book. Anyway, you can study those fallacies. But it's theory that tells us what is the relationship. And theory is the story that explains how one thing affects another. Now, there are positive and negative relationships. And positive relationships are such that if one variable changes, it causes the other variable to change in a positive direction also. If the first variable decreases, then the second variable decreases as a consequence. There are lots of examples of positive relationships. The more you study, the higher your GPA. If the studying goes up, the GPA goes up. The more beer I drink a day, the heavier I get. On and on. I mean, price. If the price that sellers are going to receive for a good goes up, the quantity they will offer for sale goes up. That's the supply relationship. There are negative relationships, and those are if the independent variable, that's the one that is causing the change, if the independent variable goes up, it causes the dependent variable to go down. They move in opposite directions. If the independent variable goes up, the dependent goes down, then the dependent variable goes up. What this means is that's a negative relationship. An example of a negative relationship is good old demand. If the price of a good goes up, what will happen to the quantity that people buy this week in our market? And the answer is it'll go down. So that's an inverse or negative relationship. Negative relationships have a negative slope. Slope is equal to the ratio of rise over run. So when we look at a diagram, this has a negative slope because if we run 3 units, it doesn't matter how far we run, just run some distance, and then go and hit the hill again, let's say you have to go down 6 units to hit the hill. The rise is, it's -6. The rise is -6 over 3, so our slope is -2. The lesson here is, first of all, what is slope and how you calculate it as a ratio of rise over run. But the second thing is that negative relationships graph downward from left to right, whereas positive relationships graph upward from left to right. The independent variable is normally the one that is causing the change, and the dependent variable is dependent on the original one. So, in the case of my beer consumption and my weight, the independent variable is how much beer I drink, and then my weight depends on it. Now, when we look at any relationship, it turns out that when it comes to my weight, there's more to it than just how much beer I have. How rich my diet is, how active I am, how much exercise I get, on and on. All of these things affect my weight. But when I'm looking at the relationship between beer consumption and my weight, that's a dependent variable, I assume that all of these other things don't change. So when we look at a relationship, we look at it, where is it? Ceteris paribus. That is, all of the other things that can affect, in this case, my weight, besides beer consumption, is held constant when we study the relationship. So for an example, this is the equation of a straight line. Straight line, well, first of all, y is the dependent variable. X is the independent variable. B and M are both constants. They're both constants. M is the slope term, and B is the y-intercept. Now, I am moving towards something here. So, for instance, my pay, I just made this up. My pay it depends on the number of hours I work, my pay rate is $20 an hour, and I get $200 just for showing up the week. I realize. Now, taxes and other things are all assumed to be constant. So, if I work 0 hours, my pay rate, my take-home pay is $200. I guess we're assuming 0 taxes. If I work 1 hour a week, then my total pay will be $220, etc. If I work 2 hours, it'll be $240. So, because the slope, that is, every time I work another hour, my pay goes up by $20. There's a constant slope, and that's a straight line. Naturally, it assumes that everything else changes. Is constant. Now, there are two things that are important to know, and this is the point to this whole discussion, and that is, when you have a relationship, especially a straight line relationship like we're dealing with here, what happens if the value of the independent variable changes? What happens if the value of the independent variable changes? So our independent variable is hours worked here, and if we change it from 1 hour to 2 hours work, we simply move from point A to point B along the diagram. Along the diagram. So it's a movement from point A to point B. That's the answer to the first question. What happens if the value of the independent variable changes? We simply move from one point to another. What happens if the value of a constant changes? What happens if, for instance, instead of my getting $200 just for showing up, I only get $100 for showing up now? Times are tough. Well, what will happen here is we will get an entirely different relationship, an entirely new set of points. When I work 0 hours, I get $100, not $200, and then for every additional hour worked, my pay goes up $20. So, what happens if the value of a constant changes is we get a shift of the entire relationship. Now, this is particularly relevant when we talk about the relationship between price and quantity supplied, or price and quantity demanded for that matter. So, for instance, if this is the demand relationship, this is quantity demanded, this is, unfortunately is the dependent variable, price is the independent variable. If the price is $2, then the quantity demanded is going to be that much. And if the price changes, remember, that's the independent variable, price, to $3, we move to a new quantity demanded, QD2 here. But price isn't the only thing that determines the quantity demanded of a good. Things like income, tastes and preferences, the price or availability of related goods, the number of buyers in our market, or expectations. All of these things are assumed to be constant. Now, what happens if one of them changes? We get a shift. This is an increase in demand, and it means that the quantity at every possible price will be larger. This is a decrease in demand, a shift left. So, relationships, dependent, independent, positive, negative, slope, an example, ceteris paribus and what it is, and then the big payoff here. What happens if you change the value of the independent variable? You just move from one point to another on the graph. How do you get a shift? A shift happens if one of the constants changes. That's it.